All right, on Friday we started talking about dilations. Let me give you a few real world examples of dilations. So, if you need to take a wallet size picture and make it hanging size, you're going to dilate. If you zoom in on your camera, I know I've done this, that's a dilation. Criminal investigators, they have to dilate, scan those fingerprints really, really big. Architects build little bitty models and they make them life size buildings. Sometimes when they go in and do surgeries, they do dilations to make it stretch or bigger so they can do what they need. Your eyes, your pupils, you dilate those when you go to the eye doctor, of course. So let's look at a couple of things here that we talked about to help. First of all, you have a pre-image, which is your beginning image, and then you get a new image. So pre is the beginning, image is the new. You can have a reduction, which is where it goes smaller, it shrinks, or you can have an enlargement where the shape gets bigger. If your scale factor is greater than 1, you're going to get an enlargement. If it's between 0 and 1, you get a reduction, and if it's 1, you get exactly nothing. It's just the same shape all over again. K is what represents our scale factor, and that is what we multiply by. And we're going to talk a little bit about lines are going to come in, so you can have an enlargement and a reduction of a line. So enlargement, you notice it going out farther. A reduction, it's a shorter type array. And this is going to be our formal notation that we're going to be seeing with our dilations. They're going to use a D for dilation. If you think about your other reflections, they can use a T for translation, R for reflection. On the O, it's the center of the dilation. The K is the value of the scale factor. So given our pre-image x comma y, we took K times x, K times y, and we get our new image point. Properties, angle measures stay the same. Parallelism, that means things that were parallel are still parallel. Collinearity, points on line remain the same and distance is not preserved. That means your distance can change. If we look at our transformation properties, distance are different, they're proportional. Orientation is the same, that means the shape is maintained, it keeps its same shape. Special points, the center of dilation is a point and does not move in dilation. If the pre-image equals the image after dilation, then the point P was the center of dilation. We'll see a picture of that, I believe, here in just a minute. So here's some more lines they're talking to us about those images. I like this picture though, because this is when the point's not on a line. So we're going to see here in the next few days, we're going to talk about these lines that come out of these points. If you've done art, you've kind of done some with perspective lines, and that's what it reminds me of. I don't know if it's exactly the same. And we'll talk about how it actually shifts the line over, but they remain parallel. So here we also have some where our point is out here, and these are our two new shapes. They're not necessarily inside each other. So scrolling down, and you can actually have a negative. I wasn't aware of that. Of course, there's rotation and stuff happening in this, so that's what causes a little bit different, and it shows how they flip. I'm not sure that we're going to get too much into that right now. These were the three I wanted to show you. So this is a center of dilation where it's on the inside, center of dilation where it's exactly on the line, and this is a center of dilation where it's on the outside. So just some perspective to get in your minds to help you as we go through. And this is what you do when O, the center is O, is the origin. So this is what we worked with on Friday. Now today we're going to lead into what happens when it's not the center. Okay, and that will be this lovely little formula right here. Don't let it scare you. It's a lot of the same numbers and you just have to plug them in. But we'll work on that and get into our graphing today. Your 17.1 activity sheet that we're working on Friday that I'm going to spend about 15 minutes on today. Your 17.2, which there's only about 12 problems. There's some graphing on it. All that won't be due till Wednesday. On Wednesday, we'll finish out 17.3 because on Tuesday, we're going to do a graphing activity, online graphing activity. On Wednesday, we'll do 17.3. We'll make that due on Friday, and then we'll be ready to start into similarity. That's what 17.3 leads into. A few more days. We're almost there. All right, guys, let's get started. Let's go ahead and get out your 17.1 answer document sheet and let's load up that PDF. It's in the About section.